Hi, so for today we're going to talk about the integrals of powers of trigonometric functions. And as you can see here, we have an integral that is equivalent to the integral of sine of x raised to 5, cosine of x raised to 8 dx. So how are we going to solve this integral? So first of all, if you see this integral, you first pick the function that is raised to an odd number. So in this case, we have sine raised to 5th of x. Okay, so what are we going to do is to strip off one sign from that trigonometric function. So we have sine raised to 4x x cosine raised to 8 of x, multiply it by sine of x dx. Okay, we have stripped off the one sign from this function. Okay, and our goal is to make these two terms equivalent to each other or the same trigonometric function. We have to make this a cosine. Okay, so as you can recall, we have the integral of sine squared of x raised to squared, that is still equivalent into this cosine raised to 8 of x. Oops, let me just rewrite my cosine. That is cosine raised to x times sine of x dx. Okay, if you wish to recall, we have a Pythagorean identity, sine squared x plus cosine squared x is equals to 1. We have here sine squared x, so we have to express this into sine squared x. So sine squared x is simply what? 1 minus cosine squared x. So if we're going to replace this integral, okay? So integral of the 1 minus cosine squared x squared. Okay? We have a square here, so we have to put a square here. Cosine raised to 8 of x, multiply it by sine x dx. Notice here that we can use the U substitution here. Okay? We can really use the U substitution here if we let U is equivalent to cosine of x, and to get du with respect to x, that is negative sine of x dx, of which we have already here the sine of x dx, but in our corresponding derivative we have negative, so we have to offset a negative sign outside of the integral. So we have now replacing that by u. Cosine of x is u, so we have 1 minus u squared. This is our squared, u squared, and raised to squared. Then our u here is cosine of x, so that is u raised to 8, and then du. Now we can perform the integration because this is only power formula. So let's expand this. 1 minus 2u squared plus u raised to 4 times u raised to 8 du, and distributing the u raised to 8, we have u raised to 8 minus 2u raised to 10 plus u raised to 12. Okay, so that is still du, and if we're going to get the integral of that, that is the u raised to 9 over 9 minus 2 u raised to 11 over 11 plus u raised to 13 over 13 plus c, and distributing the negative sign, we have negative u raised to 9 over 9 plus 2 u raised to 11 over u raised to 11, or simply 11, I'm sorry. Okay, simply 11 plus or negative, I mean negative, minus u raised to 13 over 13 plus c. And what are we going to do is to substitute again what is our u. Okay, what is our u again? Our u is what? Negative or cosine. So this would be negative cosine raised to 9 of x over 9 plus 2 cosine raised to 11 of x over 11 minus cosine of 13 of x raised to 13 of x over 13, that is plus c. So we got now the integral of this power of integral, okay, of trigonometric function. So for our number 2, we have to evaluate the integral of cosine raised to squared x dx. Okay? So in this integral, we have to use the identity, okay? The identity that this cosine squared of x is basically equivalent to 1 plus cosine 2x over 2. Okay? So we have now the integral of 1 plus cosine 2x over 2 dx. And from that, we can integrate it separately. So we have here the integral of 1 half of dx plus the integral of cosine of 2x over 2 dx. So we can evaluate simply the integral of 1 half dx, and that is basically x over 2, okay? X over 2, 1 half of x, plus, okay, 1 half integral of cosine 2x dx. So x over 2 plus 1 half. Okay? So our cosine dx, if you're going to get the derivative of, or the integral of cosine 2x, that is basically basically sine 2x. We have sine 2x, okay, over 2 plus c, okay, and that is x over 2 plus 1/4 of sine of 2x plus c. But we can express sine 2x as x over 4 plus 1/4. Sine of 2x is equivalent to 2 sine of x cosine of x. Okay? That is an identity. So we have to express this into 2 sine of x cosine of x plus c. My mistake, this should not be 4 but rather 2. Okay? So we have here x over 2 plus 1/4 sine 2 sine of x cosine of x, that is x over 2 plus, again, the 2 here will cancel, so sine of x cosine of x over 2 plus c. This will now be our final answer. So for number 3, we have to get the integral of secant 6 of x tangent squared x dx. So again, our goal is to strip off one of the trig functions here. So we have to make this to strip off one secant squared x, okay? So the integral of secant raised to 4x tangent squared x multiplied by that secant squared of x dx. The very reason I stripped off secant squared x from this function is that we can use tangent squared x as u, and we have already the derivative secant squared x dx. But the problem is we have to express this also in terms of tangent, so we can use the U substitution. So that is equivalent to integral of secant squared of x raised to 2 tangent squared of x, multiply that by secant squared of x dx. Okay, in this case, what we're going to do is what? We're going to again recall the basic identity that we have learned, Pythagorean identity, that secant squared of x is equals to 1 plus tangent squared of x. So we can replace the secant squared of x simply by the integral of 1 plus tangent squared x squared multiplied by tangent squared of x times secant squared of x dx. So as you can see here, we can now use the U substitution if we let U is equal to tangent of x and we let du, okay, with respect to x is secant of squared x dx. Secant squared of x dx is now available here. So we can use the U substitution, and that is the integral of 1 plus tangent x is U. So this is tangent squared raised to x, tangent squared x. So we have U squared, and that is raised to squared. Multiply it by U squared, multiply it by du, because the secant squared x dx is simply the du. So we have now to evaluate the integral, that is 1 plus 2u squared plus u raised to 4 times u squared du, and distributing u squared, we have u squared plus 2u raised to 4 plus u raised to 6 du. So evaluating that, our integral is in the form of power. So we have u cubed over 3 plus 2u raised to 5 over 5 plus u raised to 7 over 7 plus c. And again, our chosen u is tangent. So we have to substitute it back to its original function. So we have tangent of cube of x divided by 3 plus 2 tangent raised to 5 of x divided by 5 plus tangent raised to 7 of x divided by 7 plus c. So we have now our answer for that integral. Okay? So continuing our discussion for number 4 problem, okay, we have here number 4, that is the integral of secant raised to 5th of x times the tangent of cube of x dx. So in this case, what are we going to do, since we have a both add raised to exponent 5 and 3? So we have to find a way, okay, to strip off one of them or maybe both of them. So what are we going to do is to integrate. So I have to strip off one from one of them. Okay, secant raised to 4 of x tangent squared of x, and that is multiplied by secant of x tangent x, so dx. Okay, so I've done that. In order for us to let u as secant, because we have now here the available derivative of secant, okay, secant x tangent x, but the only problem is we have to make this tangent squared of x equivalent to secant also. Okay, express this tangent squared of x into secant for us to use the u substitution. So we have now that is equivalent to integral of secant raised to 4x and tangent squared x. If you're going to recall what we have used a while ago, secant squared x is equals to 1 plus tangent squared x. So in order for us to get tangent squared x is now simply equal to secant squared x minus 1. So we are going to express this as secant of squared x minus 1. Multiply that by secant of x tangent of x dx. So we have now our integral. Okay, so we now let u equal to secant of x. We now let du with respect to x as secant of x tangent of x dx, and that is available on our function, this is secant of x tangent of x dx. So we can simply replace this by the secant of x by u raised to 4, multiply that by u squared minus 1, then again du. Okay? So simplifying, now we have u raised to 6 minus u raised to 4, and that is du. So in order for us to get the integral of that by power formula, u raised to 7 over 7 minus u raised to 5 over 5 plus c, and back substitution. So we have u raised to 7, our u is secant here. We have the secant here. So that is secant raised to 7 of x over 7 minus secant raised to 5 of x over 5 plus c. So this is our integral for now. So for problem number 5, so we have to get the integral of the cosecant raised to 6 of x times cotangent squared of x dx. So in this case, we have to strip off the cotangent. Okay, so we have cosecant 6 raised to 6x of we have here the cotangent squared of x dx. So sorry, we have to strip off cosecant in order for us to get a u of cotangent squared x. So cosecant raised to 4x cotangent squared x, then that is multiplied by cosecant squared x dx. The reason for stripping off cosecant squared x is that we can use it as a derivative of cotangent squared x. Okay? So the problem is we have to express this cosecant raised to 4x in terms of cotangent. So what are we going to do is that the integral of cosecant squared of x raised to 2, that is cotangent squared of x, multiply it by cosecant squared of x dx. And cosecant squared of x is basically equal to 1 plus cotangent squared of x. Okay? So we can express this cosecant squared of x as 1 plus cotangent squared of x squared multiplied by cotangent squared of x, okay, multiplied by cosecant squared of x dx. So as you can see here, we can now use the U substitution. We have to let U as cotangent of x to get du over dx, that is negative cosecant squared of x cotangent negative cosecant squared x only. Okay? Negative cosecant squared x dx. Okay? So again, we have to offset negative value outside of the integral. So we can perform now the U substitution. So letting U as cotangent x, we have 1 plus, we have the cotangent squared x here, so that is 1 plus u squared raised to squared. Multiply it by cotangent squared, that is u squared. Cosecant squared x dx, that is du simply. And again, negative of the 1 plus 2u squared plus u raised to 4, multiply it by u squared du outside. So simplifying further, we have the u squared plus 2u to the 4th plus u raised to 6 du. Okay, and we have to get the integral of that. So u cubed over 3 plus 2u raised to 5 over 5 plus u raised to 7 over 7 plus c, and distributing the negative sign. So we have negative u cubed over 3 minus 2u raised to 5 over 5 minus u raised to 7 over 7 plus C. And now back substitution. So we have U is equivalent to cotangent. So we have negative cotangent cube of x over 3 minus 2, okay, cotangent raised to 5 of x over 5 minus cotangent raised to 7 of x, okay, over 7, then plus c. So this should be our answer. Okay? So that should be our answer for the number 5 problem. So if you find this video helpful, don't forget to thumbs up, okay, in this video, and subscribe to my channel for more videos in tutorials in um, integral calculus. Thank you so much, and God bless.